डियर स्टूडेंट, हमारे इस ऑनलाइन एजुकेशन के प्लेटफॉर्म पर हार्दिक स्वागत है। मैं संदीप सारण, व्याख्याता भौतिक विज्ञान, आप सबके सामने एक बहुत अच्छे टॉपिक के साथ प्रस्तुत हूं और इस टॉपिक की मैं व्याख्या करने की कोशिश करूंगा ताकि आपको इसका बेनिफिट सभी एग्जाम में मिल सके। चाहे वो सीबीएसई के स्टूडेंट है, आरबीएसई के, या कोई भी बोर्ड है, उन सब के लिए काफी बेनिफिशियल टॉपिक है। हमारा टॉपिक रहेगा कैपेसिटेंस ऑफ पैरेलल प्लेट कैपेसिटर। पैरेलल प्लेट कैपेसिटर के लिए कैपेसिटेंस कैसे होती है, इसके बारे में हम आज चर्चा करना चाहेंगे। मैं शुरू से इस टॉपिक को आपको समझाता हूं और इसका डायग्राम समझाता हूं। हम क्या करेंगे कि एक पैरेलल प्लेट कैपेसिटर, वी टेक ए पैरेलल प्लेट कैपेसिटर, दिस प्लेट इज ए, or we can say that we give the name of this plate is X. It is insulating material, metallic plate, and positive charge given to this plate. Then we take another plate of equal dimension, that is Y, placed slightly away from this, and the difference between these plates we take small d. This is the separation between these two plates. Due to the mutual inductance, or induced charge produced here, and it has the negative nature in inner side and positive charge induced on the further side of this plate. And when we earthed this plate be earthed, then free electron from the earth, the free electron neutralize this positive charge, and this positive charge disappear from the outer side of this plate. Due to this appearance of this positive charge, electric field outside is zero, and these are the metallic plates, so here electric field also zero. But in between them, here electric field exists, and this electric field is E, and having direction from plate X to plate Y. Due to the presence of this charge, so this have the surface charge density positive sigma, and Y plate have the surface charge density negative sigma. Now we find out the capacitance or storage power of this device. This device is generally used. This is generally used, and we find out the potential. First we find out the potential, then with the help of formula C is equal to Q upon V, put the value of V, we easily find out how much charge stored by this capacitor and what will be the capacitance of this parallel plate capacitor, and how capacitance of parallel plate capacitor be raised, and what factor, and those what are the factor that helpful to rise their capacitance. So we discuss the derivation first, and then factor affecting the capacitance we discuss one by one. So let us take two plate X and Y. First plate is this and second plate is this, having surface area A. Both are equivalent in dimension. It means that both have the same length, same breadth, and same thickness. So a surface area is capital A and separated by the small distance small d. They are separated by distance d. Positive sigma and negative sigma be the surface charge density of plate X and Y respectively. This have charge positive, so its surface charge density have the sign positive. Due to this presence of negative charge, Y plate have surface charge density in negative sense. And we know very well surface charge density have the formula charge upon unit area. Mean charge per unit area is known as the surface charge density. We know very well. So here we see that due to presence of charge on plate, electric field produced in between them is E. But right side of plate Y and left side of plate X, electric field be zero. Electric field be zero. Because this is earthing part and these are the metallic plate, and metal plate have electric field in left side zero. So due to this electric field potential between plate is, as we know very well that potential is equal to electric field intensity into sep. So due to potential, due to electric field present inside the plate, electric potential also set up here. And electric potential have the formula electric field intensity E into separation between the plate D. So V is equal to E into D. By using Gauss law, we calculate value of electric field intensity, and one question arises in your mind is that electric field intensity as we move away from positive plate towards the Y plate, as we move away from the plate, electric field intensity varies or it may be constant. This question generally asked and kept into the mind. As we move away from electric field may be changed or remains constant. Kept in mind, in case of Gauss law application, we already discussed electric field intensity for conducting or non-conducting plate be independent of distance, mean E independent of R0. It means that as we move away and we move towards the plate of X, there is no change in the strength of electric field intensity. So electric field intensity E remains constant in this gap. Is it clear? So by using Gauss law, we calculate value of electric field intensity. Electric field intensity is equal to sigma upon epsilon naught for conducting plate. This is the conducting plate, and sigma, put value from equation first, then electric field intensity B, sigma is Q upon A. This equation we can say that's equation second. In this way we can find out the value of electric field intensity in the form of this A upon epsilon naught. Put into equation second, then we get the value of electric potential V is equal to charge upon A epsilon naught into D. If we have calculate value of electric potential, then easily we find out the value of capacitance. By definition, here I will write by definition, capacitance C is equal to charge upon potential. This is the formula for capacitance, and we already calculate value of potential, this Q upon A epsilon naught into D, and put here value, then we get the capacitance Q upon value of potential from equation third. We put here, it will be Q upon A epsilon naught, here D. Q cancel to Q and capacitance became A epsilon naught upon D. This is the capacitance in vacuum. In any medium, in any medium, in any medium, it became capacitance C is equal to A epsilon naught epsilon R upon D, Cm. We can say that Cm, M stand for medium, and epsilon, this relative permittivity change, but there is no change in the dimension, mean there is no change in separation between plate, and there is no change in the area of this plate. Only medium may vary. And finally, we write as, we can say that Cm is equal to epsilon R time of C. So finally, we can say that electric capacitance of capacitor may be increased epsilon R time to the capacitance of this capacitor in vacuum. Here epsilon R is called the relative permittivity. So we write here, this is relative permittivity. Relative permittivity. We already discussed about this. This is the topic of capacitance of parallel plate capacitor. In this way, we can solve this. And this is very important article. Now we discuss this, some importance about this topic as. With the help of this formula, we find out that capacitance of capacitor is equal to epsilon naught A upon A epsilon naught upon D. This is the formula in vacuum. In vacuum. So factor affecting the capacitance. मीन कौन से फैक्टर हैं जिस पे कैपेसिटेंस डिपेंड करेगी, हम उस पर चर्चा करने वाले हैं एक एक करके। फर्स्ट फैक्टर है हमारा सी, किस पे डिपेंड करता है? ए पे। फर्स्ट है एरिया ऑफ प्लेट, एरिया ऑफ कंडक्टिंग प्लेट, कंडक्टिंग प्लेट, और एरिया ऑफ कंडक्टिंग प्लेट के प्रोपोर्शनल इफेक्ट होता है। फर्स्ट फैक्टर है ये। सेकंड फैक्टर है सेपरेशन बिटवीन कंडक्टिंग प्लेट, between plate of capacitor, plate of capacitor. It means that C inversely proportional to separation. It means that as we increase the separation between the plate, capacitance increase. As we increase the value of D, as we increase the value of D or separation between plate increase, capacitance decrease. As we decrease the separation between these plate, mean both plate come close to one another, then capacitance ultimately rise. This is inversely a fact. Third, medium in between plate. So medium also affect. As we introduce the another medium in between these plate, then capacitance ultimately raised. Mean this is affected by the presence of medium. Which type of medium? So we get in the presence of medium, it became epsilon or R time to this C. So as we increase the value of epsilon R, mean we introduce the medium which have high value of epsilon R, then we can say that its capacitance of this capacitor in the presence of this dielectric medium increases. We also derive the derivation as. So now we discuss if parallel plate capacitor with a conducting slab, how much its capacitance varies. So we take as like this, this is the first plate X, and this is the second plate, that is Y. And we already discussed this carry positive charge, and here negative charge induced here. Here negative charge induced in this plate in the inner side. So if there is no any medium present here, then electric field intensity be E naught. We can say that it is electric field intensity E naught in this direction. When no medium present inside it, it is the vacuum case, and surface charge density B, here surface charge density for this plate plus Q and for this plate minus Q. And separation between these two plates is D. Now, we introduce now, first we say that let us take a parallel plate capacitor having area of each plate capital A, and separation between plate is small d. In vacuum, electric field intensity between plate is E naught. So capacitance B, C naught is equal to epsilon naught A upon D. We can say this. C naught represent the capacitance in vacuum. Now, when vacuum situation is here, then this total space have electric field intensity E naught. Now, we introduce a conducting slab. Here, we introduce a conducting slab as like this. This is the conducting slab of thickness T. This is conducting slab of thickness T. We placed a conducting slab of thickness, a conducting slab of thickness T in between plate X and Y. Property of conductor is that electric field inside the conductor is zero. Here electric field is zero. Mean the space occupied by this conducting slab is free of electric field intensity. So potential difference, here we write that electric field intensity inside the conducting plate, be zero. This is the property of conductor. So potential between plate is this is potential V. अब हमारी पोटेंशियल जो होगी इनके बीच में, वो पोटेंशियल क्या हो जाएगी? इलेक्ट्रिक फील्ड इंटेंसिटी E नॉट इंटू थिकनेस, और थिकनेस हमारी D माइनस T रहेगी. ये इंपॉर्टेंट चीज है यहाँ नोट करने की. देखिए कैसे E नोट इस स्पेस में है, मैं रेड पेन से बना देता हूं जहां जहां E नोट है. ये E नोट का पार्ट है, यहाँ भी E नोट है, यहाँ भी E नोट है, और ये बीच वाला पार्ट है जो कंडक्टिंग स्लैब डाली हुई है टी थिकनेस की, इसके अंदर ई नोट नहीं है। पहले यहां भी थी, इस केस में यहां भी थी, क्योंकि पूरे के पूरे स्पेस डी डिस्टेंस के बीच में आपका वैक्यूम था, और वैक्यूम था तो उस समय आपकी इलेक्ट्रिक फील्ड और इलेक्ट्रिक पोटेंशियल थी। अब इलेक्ट्रिक पोटेंशियल कौन सी होगी? दो तरह की पोटेंशियल, एक ई और एक ई नोट। ई नोट का पार्ट कितने पार्ट में? टोटल डी है, इसमें से टी को माइनस कर दो, और रिमेनिंग पार्ट किसका हो गया? ई का। प्लस वी राइट प्लस ई इंटू टी। दो पार्ट में हमने पोटेंशियल को तोड़ लिया, और ई की वैल्यू क्या है? 0। पोटेंशियल क्या बन जाएगी हमारी? ई नॉट इंटू डी माइनस टी प्लस 0। ये वाला पार्ट आपका 0 हो जाएगा, क्योंकि कंडक्टर के इनसाइड में इलेक्ट्रिक फील्ड क्या होती है? 0। तो अब हमारी जो पहले पोटेंशियल थी उस पोटेंशियल से कम पोटेंशियल होगी हमारी, और गाउस लॉ से हमें पता है सब चीजों का, तो गाउस लॉ से हम पुट कर देंगे बाय यूजिंग गाउस लॉ। इलेक्ट्रिक फील्ड इंटेंसिटी ई नोट किसके बराबर होती है? सिग्मा अपॉन एप्सिलॉन नॉट। कंडक्टिंग प्लेट के लिए होती है ये, सिग्मा अपॉन एप्सिलॉन नॉट। और सिग्मा की वैल्यू क्या होती है? आप सब जानते हैं सिग्मा क्या होता है हमारा? सिग्मा होता है चार्ज अपॉन एरिया। यहाँ हम साइड में लिख देंगे सिग्मा इज इक्वल टू चार्ज अपॉन एरिया। जैसे ही ये हमें ई नोट का पता लग गया, हम इस ई नोट को उठा के कहाँ रख देंगे? इस ई नोट को उठा के हम यहाँ पे इंट्रोड्यूस कर देंगे, तो पोटेंशियल जो हमारी बनेगी वो Q अपॉन ए एप्सिलॉन नॉट इंटू डी माइनस टी बन जाएगा। ये आपकी पोटेंशियल की वैल्यू आ गई। जैसे ही पोटेंशियल की वैल्यू आएगी, आप क्या करेंगे? फॉर्मूला लगा देंगे कैपेसिटेंस का। बाय डेफिनेशन इसको फर्स्ट इक्वेशन कह दो, इसको आप थर्ड इक्वेशन सेकंड इक्वेशन कह दो। बाय डेफिनेशन C is equal to Q upon V, and Q is Q, and value of V is this. This is the value of V put here. Q d minus t upon A epsilon naught. We introduce A epsilon naught here. Q cancel to Q, this Q cancel to this Q, and remaining part we get here. C is equal to A epsilon naught d minus t. Now this is the new value of capacitance in the presence of a conducting material. Here this is conducting material. Due to the presence of conducting material, electric field inside or in between the plate remains 0. So in this part electric field is 0. This electric field due to value 0 do not take part in potential. So this part cancel, and if value of potential decrease, it means that capacitance increase. Now capacitance increase due to the presence of this, and this is the formula of capacitance in the presence of conducting material. We can say that if we rearrange this here, I rearrange this as we take common d from lower side. This becomes C is equal to A epsilon naught upon d. We take common 1 minus t upon d. This term became as like this. D we take the common, and from equation first you see from here epsilon naught A upon d, A epsilon naught upon d, this term became C naught, and this is 1 minus t upon d. Here we can say that C greater than C naught. C greater than C naught. And finally we write that capacitance of capacitor. Capacitance of capacitor increase due to presence of conducting slab. conducting slab in between plate of capacitor. So finally we can say that by introducing the conducting plate, capacitance ultimately rise. This is very important. C greater than C naught. When we introduce the conducting plate in between these, or conducting slab in between these plate, its capacitance rise. Now we see what effect on the capacitance when non-conducting slab is introduced. So the next topic is when parallel plate capacitor filled with dielectric slab, what effect on their capacitance we discuss here. As this is the parallel plate capacitor, we take the plate A and this is another plate. This plate is X, this plate is Y. It carry positive charge, and this due to this positive charge, negative charge induced here. Negative charge induced here, and electric field intensity be E naught. Now, E naught means there is no any medium present. Now, this have the surface charge density plus sigma, and this have negative sigma, and separation between them is D, and area of plate is same. Let me write here. Let us take a parallel plate capacitor. Let us take a parallel plate capacitor having area of each plate, capital A, and separation between plate small d in vacuum or air. Capacitance of capacitor is we represent this as C naught, that is A epsilon naught upon E, D. This is the value of capacitance in vacuum or air. At this time, we not introduced any medium here. Then in this situation, capacitance of capacitor is this in vacuum. Now we introduce a dielectric slab of definite thickness. So we consider this is the dielectric slab we introduce here, and you kept in mind that thickness of slab is smaller than the separation between these plate. This is dielectric, not conducting. In previous article, we introduced this conducting plate. So inside the conductor, electric field is zero. But now we use it dielectrics. What do you mean by dielectrics? Dielectrics are those substances, they behave as insulator at room temperature, but in the presence of electric field, they electrified. मीन ये इलेक्ट्रिफाइड हो जाएंगे जब इलेक्ट्रिक फील्ड होगी, और यहाँ इलेक्ट्रिक फील्ड है हमारे पास, तो क्या होगा, इस वैक्यूम की इलेक्ट्रिक फील्ड के कारण ये आप इसमें इंड्यूस्ड चार्ज प्रोड्यूस होंगे, और जिसको हम कह सकते हैं कि इसके जो मटेरियल के जो पार्टिकल हैं, इस डाइलेक्ट्रिक्स के सब्सटेंस के जो पार्टिकल है वो पोलराइज्ड हो जाएंगे, और पोलराइज्ड होके इलेक्ट्रिक फील्ड अलग बनाएंगे, और वो कैसे पोलराइज्ड होंगे, पॉजिटिव पार्ट इधर नेगेटिव आ जाएगा, इधर इस चार्ज पॉइंट पे नेगेटिव चार्ज इंड्यूस हो जाएगा, और इधर आपका पॉजिटिव चार्ज इंड्यूस हो जाएगा। ये किसकी वजह से होता है, ये ध्यान रखना, ड्यू टू पोलराइजेशन फिनोमिना हैपनिंग हियर इज पोलराइजेशन। पोलराइजेशन फिनोमिना मीन when any dielectric substance placed inside the strong electric field their molecule get polarized and there is shifting of positive and negative charge particle inside the dielectric. And due to presence of this, a new electric field setup, that is E, and K be the dielectric constant. Here we write as we introduce a dielectric slab of thickness T less than D, having dielectric constant K under the effect of electric field E naught. It polarized and electric field E produced inside the slab. Then potential between capacitor plate X and Y became as potential. We know very well that potential V is equal to, it is the equivalent to the electric field into separation between plate. Here two environment exist. One have the electric field intensity E naught and other have the electric field intensity E. And due to E naught, different potential formed, and due to presence of this new electric field inside the slab E, a new type of potential create here. So this part have different potential and outer part have different potential. Potential is scalar quantity. It can be simply added or subtracted with the help of simple law of algebra. So total potential must be equal to the potential of this dielectric slab and potential of remaining part of this parallel plate capacitor. So we write as E naught electric field into distance in which E naught affected. जिस पार्ट में कितने डिस्टेंस के अंदर ई नोट का इफेक्ट है, देखेंगे तो ई नोट का इफेक्ट यहाँ है और ई नोट का इफेक्ट यहाँ है, और सेपरेशन बिटवीन कितना है डी, टी पार्ट में नहीं है, तो डी में से अगर टी को माइनस कर दे तो रिमेनिंग पार्ट्स हो जाएगा जिस पार्ट में ई नोट का इफेक्ट है। तो यहाँ क्या बनेगा, डिस्टेंस डी माइनस टी प्लस सेकेंड पोटेंशियल ई के कारण है, वो कितने पार्ट में है ई का इफेक्ट, टी पार्ट में है। ये आपका फॉर्मूला बन जाएगा हमारा सेकंड फॉर्म कह सकते हैं हम इसको। हम रिलेशन जानते हैं, बट वी नो दैट E upon E naught is equal to K, sorry, E naught upon E is equal to K। ये रिलेशन हम अच्छे से जानते हैं। रेशियो ऑफ इलेक्ट्रिक फील्ड इंटेंसिटी इन वैक्यूम टू मीडियम इक्विवेलेंट टू द डाइलेक्ट्रिक कांस्टेंट। Here I can represent in this way. Let us consider there are two charge plates, one have positive charge and then have negative charge. So electric field intensity due to positive charge in vacuum is AQ upon, here K is 1 upon 4 pi epsilon naught Q upon R square. This is the electric field intensity in vacuum. Same phenomena, charge is same and distance between this point is also same, but medium is changed. We write as 4 pi epsilon naught K Q upon R of square. Here K is dielectric constant, it is also written into epsilon R also. So divide these two equations, 4 pi epsilon K Q R square cancel. and we get E naught upon E is equal to 1 upon 1 by K, and we replace this, it get be K. So this is the formula comes from here, and we get here, it can be written as equivalent E is equal to E naught upon K. This is the value of electric field intensity put into above equation. This equation put into second. From equation second, we get potential V is equal to E naught D minus T plus E naught T upon K. E naught taken common. This is E naught, we take the common, and it became D minus T plus T upon K. E naught is sigma upon epsilon naught. We know very well this part, D minus T plus T upon K. Here I will write here by using Gauss theorem, E naught is equal to sigma upon epsilon naught. From the definition of sigma is charge per unit area. So we explain this charge per unit area and put this value. So first I will remove this, and second we write this part here. This is, we write here, this potential V is equal to sigma is charge per unit area, put the value charge per unit area, and remaining part epsilon naught in downward we write here, and D minus T plus T upon K we write here. Here I will put the value sigma is equal to charge upon area of the plate. This is the definition of surface charge density. By definition of capacitance, by definition, C is equal to Q upon V. This is the definition, put this value here, and finally we get the capacitance as C is equal to Q upon V. V is this, put here Q, D minus T plus T upon K, and A upon epsilon naught goes to upon upper side, and Q cancel to Q, and finally answer is C. C is equal to A epsilon naught upon D minus T plus T upon K. Again, you see, compare this equation and this equation. Lower part is D, and here lower part is decreased by some factor from D. So this value is smaller than this D. So we can say that C greater than C naught again. So finally, C greater than C naught. We write as C greater than C naught. It means that capacitance increases. Finally, we write capacitance increases in the presence of dielectric slab ultimately raised. This is very important topic according to exam. Generally in exam asked this question as like this, find out the capacitance of parallel plate capacitor when partially filled with dielectric slab. This is partially filled. So during this case we can solve this type, and finally we get capacitance also increases in the presence of dielectric slab.